Okay, we're going to look at some rules for exponents. And so this comes from a worksheet that we have, and it's try to find this page. It should be the third page. So what we're going to do is we're going to look at the situation. We have 7 to the 8th power over 7 to the 3 power. And what we've done is we've drawn, it's a fraction or a division problem, and we've extended the line here. And then in the numerator, we expanded 7 to the 8th power, so it's 1, 2, 3, 4, 5, 6, 7, 8 sevens, and the denominator is 1, 2, 3 sevens. So if we simplify that, what I can do is I can cross out when the numerator and denominator has the same factor. I can cross them out. So this 7 and this 7, 7 divided by 7 is 1. 7 divided by 7 is 1, and 7 divided by 7 is 1. So what I'm left with is 1, 2, 3, 4, 5 sevens. So 7 to the 5th power. Sorry, 7 to the 5th. Now if I think about that, I started with 7 to the 8th, and then the denominator was 7 to the 3rd, so 8 minus 3 is 5. So same thing over here with the 4s. So it's expanded form, 1, 2, 3, 4, 5 4s, and the denominator 3 4s. So I can cancel out 4 divided by 4 is 1, 4 divided by 4 is 1, 4 divided by 4 is 1. So that means I have 1, 2 4s left, that's 4 squared. Now if I think back, I started with 4 to the 5th power, and 4 to the 5th power, 5 minus 3, which is 3 down here, equals 2. So it's not always 3 a second, it's whatever is in the denominator. So here I have 1, 2, 3, 4, 5, 6, 7 b's, so b to the 7th, and the denominator 1, 2, 3, 4, 5. 7 minus 5 is 2. And if I cancel them out, 1, 1, I would have, that's a b still, I would have only 2 left. So if you think about it, before, multiplication, the rule before with multiplication was that we add the exponents. So up here, 7 to the 5th times 7 to the 3rd was 7 to the 8th. Or 7c to the 1 times c to the 4 was c to the 5th. So when you multiply like bases, you add the exponents. But when you divide like bases, you actually subtract the exponents. So if you can imagine, it's like the opposite. So that kind of makes sense. So the rule is a to the m divided by a to the n is a to the m minus n. So you can try those examples and then pause your video and try the examples. So those are the answers to the first examples. And so if we're applying the rule, you would do 6 to the 4th over 6 squared, or 6 to the 4th divided by 6 squared is equal to the 4 minus 2, and that equals 2. So we don't actually show this step typically, we just subtract in our mind and leave it that way. Okay, turn to the 5th worksheet on the packet, and we're looking for where it says rule for raising a quotient to a power, so about halfway down the page. Now this is a little bit confusing, this section, so let me just start here with the 81 over 9. So let's say we start with 81 over 9. Well, that's the same thing as 9 times 9 over 3 times 3. So I could simplify 9 times 9 over 3 times 3 and make it 9 over 3 squared. But 9 over 3 squared is the same thing as 9 squared over 3 squared. So what it's just saying is those two things are equivalent. So for example, let's say I had 2 fifths squared. Well, that's the same thing as 2 fifths times 2/5, or, which is 4 over 25, or that's the same thing as 2 squared, which is 4, over 5 squared, which is 25. Either way, I get 4 over 25. So these two things are the same. So that being said, the rule is that if you have a fraction that is raised to a power, then you can rewrite that as the numerator to the power over the denominator to that same sorry. And you can flip-flop back between those two different ways of writing it. So the algebraic rule looks like this: a over b to the mth power, or the power of m, equals a to the m over b to the m. So, and you can switch back and forth between that. Now, why don't you try the example problems down here, and then pause the video and you can check your answers. Okay, so the answers are in order: 1/8, 16 over 81, 8 and times 6 to the 6, x to the 6th power and over 27, and the last one is 125 f to the 3rd power over 343 h to the 3rd power. So they kind of complicated, but as they go through, I did want to point out though this one, because this one is probably the one that we're most commonly going to miss, because it's the negative in front of the fraction. And so we can think of this in one or two ways, if this helps you. If it's negative 2/3 being written to the 4th power, that really equals negative 2/3 times negative 2/3 times negative 2/3 times, negative 2/3. So if I think about it like that and I expand it, I'll fix that. Then that means that I have a negative times a negative is a positive, times a negative is another negative, times a negative is a positive. So when I have an even number of negatives being multiplied by each other, my answer is positive. And then 2 times 2 times 2 times 2 is 16. And then 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's why it's positive 16 over 81 if you use expanded form, or if you would have used this way too. Notice how I fixed it by making sure that I kept the parentheses around the -2 when I started. So the rest of the worksheet takes you through how you can prove what a number to the 0 power would be, and it takes you through some patterns so that you can see why it is what it is. Then after you get halfway down the page, it starts talking about when the denominator's bigger than the numerator. And so what's going to happen is you're going to have negative exponents. So there's more to learn about exponents, and we'll be doing those. We don't necessarily have to you don't have to finish this page today, but I just want to tell you that's how the packet goes, and it continues to get harder. And then the last page of the packet you have has some practice, but I don't know that we can do all the practice yet, because like number 6 has negative exponents, and so some of these things have negative exponents. So you don't have to do the ones that are circled, but the other ones you should be able to do. So let's try a couple together. Let's try number number 10. And so pause the video and then you can check your answer. So there is the answer to number 10. So you cannot distribute the squared. It's not 8 squared minus 3 squared. It doesn't work that way. You have to actually subtract the two numbers first. Another one that you should try is number 16. So I'll pause the video, try that. And that should look familiar because that was from the other page. And so that's the answer you should have. The last one I want you to try is number 19. Do number 19. So there you go. Number 19 should be 16 times x to the 6th, but I'm actually having a hard time reading that exponent there, so I'm pretty sure I'm right. Anyway, in general, let's just summarize the rules that you learned. So the two main rules we went over was when you have like bases and they are being divided by each other. So c to the x power divided by c to the y power. So since they're like bases, I can take their base c and do x minus y. So in other words, if it was 7 to the 4th power divided by 7 squared, I would do 4 minus 2 and 7. 4 minus 2 is 2, and I write 7 squared. So that would be it. And the other one we learned about was when you have a quotient and that's being raised to a power. In that case, both the numerator and the denominator get the exponent. So it goes with both numbers. So in the example of, let's say I had 4/7 cubed, that would be 4 cubed over 7 cubed, which would equal 64 over 343. Okay, so there you go. Those are the two rules we went over, and you got some practice, so hopefully it's helpful.